Hello, welcome back to Mr. Weeder Maths. We are going to carry on with the Surds work that we were doing before New Year. Happy New Year to you all. Let's get cracking. So, still got our yummy Surds over here. I'm going to show you two methods how to multiply Surds together. Method one is my favourite. Method two is going to be your backup. So, method one, we're going to break down the Surds into root 4 and root 2 is what root 8 will become. That is being multiplied by root 2 and a root 5. That is what root 10 is made of. We are then going to have a normal integer appear from root 4. That becomes a normal 2. And then, like we saw on the previous video, when you have a surd multiplied by a surd, that becomes a normal integer as well. So that becomes a normal 2. And then lastly, we've got a surd by itself, which is root 5. We can't simplify that, so we get left with this one here. And then we simplify the integers together and leave the surd on the end. So we've got 4 root 5. Your backup method, which is something that quite a few students are confident with, is combining the surd up and then simplifying down. So what I mean by that is that they will combine this up, so they will times the 8 and the 10 to get root 80, and they will look for the biggest square number in that number. Now, those of you who are really confident with your square numbers will recognize that there is root 16 in this, and 16 goes into 80 5 times. So we have root 16 times root 5. Now we can simplify root 16 to become a 4, and then the root 5 stays the same. Look at that, we've got the same answer, but two different methods. I prefer this one, and it will become clear why in a second with our later examples. So, just gonna get rid of this, and I'm gonna do the current examples with my method, okay? So, let's go for root 5 times by root 30. So we're going to do a similar thing. We're going to break down the surds we can, find matching pairs or find square numbers, and then simplify. So root 5 stays as a root 5, but I can break down root 30 into root 5 times by root 6. Okay, now I could look to break down root 6 again into a root 2 and a root 3, but because there's no matches, there's no need to do this. So I've got a root 5 and a root 5 to get a normal 5. And then because I can't break down root 6 anymore, or there's no square numbers that go into 6, we could just leave it. And that's it. Okay, on to the next one. Now, this next one is the reason why this method is superior to the previous method. Because I have root 44 multiplied by root 77. That is a horrific multiplication if you wanted to combine them up with the backup method. This method is better because I can pull these apart. Hopefully, if you spot 44 and 77, you can see that there's a number that goes into both of them. It is 11. So we are going to break both of these down into root 11 times root 4. And then the root 77, I'm going to have root 11 times by root 7. We've got our matching pair, so root 11 multiplied by root 11, that is going to become a normal 11. Our root 4 becomes a normal 2, and then the square root of 7 stays as a square root of 7 because there are no other surds. And then we would simplify that answer fully to be 22 root 7. Really, really nice, okay? It's a lovely method. Better than this one, but you've got this one in case this doesn't make sense for you, okay? Final example then is when there are integers out the front. So we've got 4 root 3 times by 5 root 21. Now we do the exact same thing. We just treat the integers as normal numbers, okay? So I've got 4 times by root 3 times by 5. So all I've done is separate these with multiplications, and then I'm going to break down the square root. So we've got square root of 7 and the square root of 3, because 21 can be written as 7 multiplied by 3. We've got our matching pair of 3. So I've got 4 times a normal 3 times a normal 5, and then the only surd that's left is square root of 7. you do the normal multiplication. 4 times 3 is 12, times the 5 equals 60 root 7. And there we go. Hope that enjoys. Go find some questions now of multiplying surds. Give it a practice. This is a yummy, yummy topic. Enjoy.